Wastewater from milk processing facilities is classified as high-concentration wastewater of unstable composition with organic contaminants included. The concentration of wastewater contaminants at different milk processing facilities varies over a considerable range. These variances stem from a diverse mix of output products: yogurt, fermented baked milk, buttermilk, dairy butter, cheese, sour cream, plain cream, ice cream, as well as from fluctuations in wastewater output and contamination rate during the day. In addition to organic substances, wastewater from milk processing facilities may also contain microorganisms that give rise to lactic acid, ethyl-alcohol, propionic-acid, and butyric-acid fermentation. A conventional flowchart for milk processing factory wastewater treatment involves the oxidation of organic contaminants and the conversion of nitrogen compounds into nitrate form. For this purpose, activated sludge is used and constitutes a biocenosis of microorganisms capable of sorbing the organic substances contained in wastewater on their surface and oxidizing them in the presence of oxygen. Oxidation is facilitated by oxygen from the air, which is drawn in by air blowers through the aeration system. The disadvantage of this method is the long duration of oxidation process, as well as the need for an additional wastewater decontamination unit if the wastewater is discharged into water bodies. In view of the above, GlobeCorp has developed a technology for improving the efficiency of milk processing factory wastewater treatment with the use of an electromagnetic vortex layer of ferromagnetic particles, such as an AVS machine. These machines use a rotating electromagnetic field and ferromagnetic particles that move along complex trajectories when exposed to this field and constantly collide with the operating chamber walls, with one another, and with the processed substance particles. Furthermore, in the machine's operating chamber, there occur intensive mixing and dispersion of constituents contained therein, as well as other phenomena that have a beneficial effect on wastewater treatment: high local pressure, water electrolysis, acoustic waves, and cavitation. In the case of using the technology of electromagnetic vortex layer of ferromagnetic particles, the wastewater treatment scheme for dairy factories can be as follows. The incoming wastewater from the tank is pumped into the vortex layer device of the AVS type. Before the AVS, air is supplied into the wastewater through an air blower. In the working chamber of the device, the outgoing wastewater and air are subjected to intensive treatment under the action of a rotating electromagnetic field, the vortex layer of ferromagnetic elements, local high pressures, acoustic vibrations, electrolysis, and other factors. After passing through the device, the treated wastewater enters a mass exchange column, where further intensive treatment is carried out, ensuring the effective oxidation process. The disinfected wastewater is then collected in another tank after the column. The use of a vortex layer machine allows increasing the oxidation rate and thus shortening the processing time to a considerable extent as compared to the conventional method, reducing the volume of air required, and improving the quality of milk processing factory wastewater treatment. Vortex layer machines have compact dimensions, can be smoothly integrated into the existing wastewater treatment flowcharts, require no special pedestals for their installation, and are easy to operate. In addition, they allow saving the electricity due to the fact that their power requirement is less than that of typical mechanical mixers and ranges from 4.5 to 9.5 kilowatts depending on the machine model. And what other challenges is your milk processing facility facing? Please share them in the comments section. More information on the GlobeCorp technology and equipment for wastewater treatment can be found by following the link in the first comment or visiting our website, www.globecorp.com.